welcome.
Welcome to Eureka.
Hello, guys. How y'all doing? You feeling it? A little sauced, maybe? Okay, work on it throughout the show.
Are you feeling stellar?
Oh, this is just the beginning of the puns.
So the first thing we would like to do is we'd like to give a huge thank you to Dent Space.
Big round of applause for Dent.
Let's give him a big applause.
My name, by the way, is Kevin Whittinghill. I'm one of the co-producers in a comic.
Yes, and my name's Alan Sakian, and I'm the other co-producer of the show and the host.
Yeah. He's a punster, huh? So yeah, let's...
Let's bring Dent down, yes.
Bring them up.
And thank you for Kickstarter as well for the sponsorship.
Yes, Kickstarter.
Thank you, Kickstarter.
Right here. Come on up.
Why don't you do it?
Oh.
Now you have him. I'll do the drum roll.
So many planets aligned for tonight to come together. And one of
the
them
bad
was,
puns continue.
At the same time, I was talking with Clarissa about how we could do something cool for our conference, our space conference. I was also talking to Eureka and Piano Fight, and then I went, oh, Piano Fight is a Kickstarter-funded venue. It's perfect. So everything came together, and Clarissa said, oh, let's do a party. And so she helped make tonight happen. And
yeah, thank you so much. You guys bring like such a diversity of perspectives to space exploration, and Kickstarter's really excited to be a part of that, even if it's just throwing a party. So.
Oh, but you guys, they're a lot more than that. They're doing sessions and exhibits at the conference. So then we were talking to our old friend, our young friend, who we've known a long time, Megan Kennedy. Megan, where are you? Oh, okay. Who said, hey, I've got a fun idea for the conference. And Megan has been a part of our Sun Valley event for years and years and years, and a very creative person that I'll dive into in a minute. But anyway, she said, is there something special I could do for you guys? And we talked about it, and here it is.
Love you, Megan.
Yay! Megan is the doyenne who does Your Piñata, which is this, covered by Huffington Post and many other press outlets, Celebrity Piñatas. Jason and I have
a joint piñata.
It's
a little bit like
twin thing. It's beautiful. Anyway, so she goes, who's really awesome that we could do a piñata of? And we said, oh, Clarissa. You should do one of Clarissa. So anyway, thank you guys. Thank you.
I want to know what's in that piñata. That's what I want to know. Is the candy there? Are we going to... I feel though I don't want to commit an act of violence on somebody I can recognize. Okay. Let's tell you about the show.
Yeah, absolutely. So Eureka is an interactive science comedy show where we demystify science in ways that are educational, relatable, and entertaining. And audience members are going to have the opportunity to answer our guest scientists' questions to earn fun theme-related prizes.
That's right, yeah, smarty pants. You might get some fun, silly prizes, so don't be shy. Feel free to raise your hand if you want to try to answer a question, or if you just have a question in general. This show is definitely about back and forth between the scientists, the host, the comics, and the audience. So just keep drinking, feel loose, and let's just, learn something and have fun.
Woo!
Yeah.
Yeah.
Well, I would raise your hand first.
Yeah.
If you remember back to grade school, that might help you. This guy's like, no way, he's a rebel.
Yeah.
Look at that fella. There it is. You're already asking a question. We're about to start. Yeah, you're just practicing?
Yeah, I was just practicing.
Okay, good. This guy's got it. Do what this guy does.
Yeah.
He nailed. Look. All right.
All right.
Woo! These guys. You're passing out deodorant sticks later on in the show. Wow. Okay. I think we're riling the audience up. And now I think the speaker's afraid to come out. But let's start by introducing the comics. Yeah.
Yeah.
All right. Guys, our comics aside from myself, we have two of the best comics in the Bay Area. Big round of applause for Natasha Muse and Kasim Bentley. Come on out.
Woo!
Natasha, come sit. Kasim. Natasha was SF Weekly, was what, best comedian in the Bay? Sure. Okay, great. And Kasim, he's in Viceland and everything else that he does, yeah.
Also,
Like,
can I point out a word, a dress that has spaceships on it?
Oh, wow.
Yeah! Woo!
That's pretty dope, right?
That is good. That is, you beat me in my like picnic table here. So that's, yeah. You didn't? Okay, I appreciate it. All right, so this is us. We're going to sit and then, yeah, let's begin.
So, what do you guys think you might talk about today?
That's good. Someone's so smart.
What do we think that we might talk about?
Yeah, what do you think? What do you think? What are your thoughts?
What we think we might talk about?
Okay, I thought so.
Yeah.
All right, all right.
Some type of thing going on?
Okay, okay.
Are we talking about planets?
Yeah, I think that's the rumor.
Okay.
Something about
But
planets.
like exoplanets, right?
So, okay. Exo.
Exoplanets. Any idea?
They sound pretty excellent.
Oh. Non-stop. You should team up with the guy. Oh, boy.
All right. So,
So obviously we have no idea what's going on. Yeah. Okay, you're done. Your job is done here. Yeah, you just got booked on Conan, I think.
space calls.
The old show that he lost.
All right. So, yeah, maybe we'll bring out the scientists to give us a little idea
Okay,
of
that
what
might
we'll be
interesting.
talking about.
Yeah.
You told us what we're talking. I didn't know.
So we will be hosting Dr. Natalie Batalha. She is an astrophysicist. Woo! Yeah!
Hello. Natasha, you didn't call me to tell me that we were wearing our space dresses.
Oh, yeah, I'm sorry.
Next.
I feel bad now.
Natalie also has an array of space clothing, just like Neil and Natasha do. So, background about Natalie is she's an astrophysicist at NASA Ames Research Center, and the mission scientist for NASA's Kepler mission. And yes, and she is definitely going to get into depth about that today, and we're really excited for that. And this is recent. In 2015, you joined NASA's Nexus for Exoplanet System Science.
Yeah, that's right.
Yeah, it brings teams together from multiple disciplines together to understand the diversity of worlds. So lead NASA's efforts to
And
understand.
search for life.
And search for life, yes, which there are multiple ways to search for life, which we will, but you do a specific search.
That's right.
So we will
Exactly.
be touching base on all of this. And yeah, Natalie is really cool. So I did a lot of homework, which I have to do for me to understand anything.
We did no homework.
And she has some spectacular videos online for you guys to watch and check out afterward. And in a lot of them, they blew my mind by the technology, all of the engineering and the work that goes into being able to discover life and what that does for us once we do. One of the cool things, she calls herself a planet hunter. Yes.
Okay.
Yes, a planet
Yes,
hunter.
yes, absolutely.
And Natalie says back in her day, we used to have 9 planets.
Eight.
Uh-oh, they're planet keepers out here? Jet fuel can't build Pluto.
Never again.
So, let's jump into some of Natalie's questions and some of the
That's
talking
right.
points that we'll be asking the audience about. We'll be asking the comics about. So, this first question: what do you comedians? What do you guys think? What are 3 ways scientists search for intelligent or even microbial life beyond Earth?
I like how like microbial was like bracketed out there.
Yeah.
Is that a particular? I mean, is that like a passive aggressive diss on microbial life?
Yeah.
Is-
Definitely was. That was assuming that they're not intelligent.
Or
Yeah.
even microbial, yeah.
The show's
Or
already
especially
bigoted right from the
microbial, right.
beginning. Search for intelligent life.
We send out old signals of our old TV shows, I think, and see if they get the jokes, then they'll send them back to us. That's one of the ways.
Wait, so I have a logistical question here. Do they get prizes too?
No, we get participation prizes.
They get drink tickets.
Yeah.
That's nice.
Yeah, thanks.
Right?
What do you get? Alcoholism.
Yeah, yeah. That is. That keeps us going. That's probably intelligent. Search for different ways. Well, certainly not through like a Facebook feed of a planet. Like that would never happen. There's nothing intelligent on
Although
like
that
Facebook
does couple
comments.
with the television theme, right? Yeah.
Intelligent life. What do you think?
I would think the first one, which would be obvious, is X-Files. I think in the first 2 seasons, I think that would be the first go around. The second would be looking for intelligent life beyond Earth. You would want to compare. You would want to compare what we already have here. You know what I mean? And saying what's intelligent. So that kind of rules out certain places like Fresno, Sacramento. You know,
That's right. That's true.
you know, certain parts of San Francisco. You can see a Boro walking on the marina. You know what I mean? Like those kind of guys. That's already there. Anything above that is like he's a genius.
What if we sent like the Mars rover to Fresno, just to like
Come
explore?
back stripped.
Yeah.
Yo, man, you want a rover? You know what I mean? That's what he's like. I want a rover for $50.
That's right.
All right. And Natasha, you wanna? Yeah.
You gonna look for like planets that look like Earth out in space?
Ooh,
Yeah?
very good, very good.
Ooh,
Yes.
and so, how? Do we have any guesses from the audience? Any
Yeah.
of the 3 ways? Okay, there's a lot of excitement right here. Yes.
Listen for non-background noise radio signals with radio telescopes.
Absolutely, excellent. I think that's a great answer. right?
Eureka!
Yeah.
Eureka.
Something. Ooh, what do we got in this little magical box?
So wait, what did he say?
He said.
He said the right answer. That's
the right answer.
What do you know? What he said? Something about radio?
Oh, what did he get? Wait, what did he get?
Wait, we
What'd
should
he get?
show what he got.
What'd he get?
Let's-
Oh, an astronaut.
It's MTV.
It is.
I think he got one of these little astronaut toys.
What do you give him? Gumball machine toys? What is this guy?
The lucky winner will get Natasha's pens, by the way.
No, those are some classic pens.
And
These are
that's
nice
So
pens.
we have the radio signals. I think Natasha actually deserves at least a drink ticket because
Nice.
she said exoplanets, right? But there's a third. We're waiting for a third, right?
okay. Yeah. Go ahead.
Jazz.
Mars and, well, lots of places, but Mars specifically.
Any other places in the solar system where we might look for water? Europa. And Enceladus. Okay,
Enceladus.
who's handing out
Took it
prizes?
right out of my
You're-
mouth.
I didn't want to say it. I didn't want to say it, but
Yeah.
We'll get. What we got. Well, yeah, we'll get. Let's see what we got in here. All right. So, I think
give him a good one, man. Come
a
on,
good
dig
one.
deep.
How about this? We got
They're
a
all
baseball
good.
hat.
What's that, Jackie Robinson?
Jackie Robinson on the.
What every
On the
white guy
moon.
needs.
You need a
Jackie Robinson figure.
astronaut.
He's like, my collection's complete.
Someone else got
I am the master.
We've got a little.
Oh, that's a good one.
Oh, Enceladus.
So
Yeah.
where are Europa and Enceladus?
The Jackie Robinson thing kind of.
Oh, wait, this riot's gonna break out.
Oh, alien.
Oh, look at him. Oh,
Got it.
Look at him. You
Success on
see
the
that?
catch. And Europa?
Oh, now we're getting lines.
Shake
Yeah.
Europa.
We'll get you another.
That's that Beastie Boys song, right?
Yeah, I think it is. Yeah.
Shake Europa.
Shake your. Totally following you.
Shake Europa.
All I want to do is a zoom, 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 and Europa. Okay.
That's not the right song.
So
No, it's
Natalie, let's expand on the things that we just learned. So the 3 different ways to.
Okay,
find life.
so we have a slide. Ah, okay. Let's see. Where am I pointing this thing? Where's the actual
There you go.
computer?
Oh,
All
hey.
right, very good. So 3 pathways for searching for life. So 1, you listen for signals. This is the SETI searches, right? Search for extraterrestrial intelligence. You listen for signals that can't be explained by some kind of astrophysical phenomenon, right? Like stars or quasars or whatever it be. And the idea is that if you see patterned noise, it would be indicative of some kind of intelligence out there that has technology like we do, that's streaming I Love Lucy, which I guess,
Yeah.
that's intelligence, right?
I think so.
I think you're right.
Yeah.
The second pathway,
Hey, Lucy, phone home.
The second
That was so
pathway
good.
is solar system exploration. There are niches in the solar system that might have intelligent life. Some even say maybe Earth has intelligent life. I don't know. But what we are looking for are places where there might be liquid water. And so we know that Mars had liquid water. In fact, it probably still does in some small niches. We've seen fluids flowing down the walls of craters, for example. On the poles, you have frozen water. And so maybe like lurking deep down in some cave, there is liquid water someplace. And maybe life is hanging out there. Or maybe it's not life, maybe it's just death, and we'll see fossils or something if we send humans there to go digging around. And then Europa and Enceladus are these icy moons of the outer gas giant planets, Jupiter and Saturn. And the reason that they're interesting is because they're covered in ice, but as you go down deep, the temperatures rise and you do get layers of liquid water. And where that layer interfaces with rock, which we think these satellites have some kind of rocky core, you might get really interesting chemistry. And maybe there's like a Loch Ness monster swimming around in the oceans of Enceladus and Europa.
And so it's...
So what you're saying is that you believe the Loch Ness Monster is real and is going through wormholes buried in the Earth that are connected to other planets?
Something like
Can I have you on record as saying that? Because
You're
I just
an
want to
write that down, Natasha.
write that
down. Yeah,
for
you
my
can quote me.
podcast.
Yeah.
that I am.
Tweet that
in
later.
this picture on
The
the
room
left,
goes dark.
Natalie. So what you just said. So Europa is a moon of Jupiter, and Juno is investigating Jupiter, the satellite, and then we have Cassini, which is investigating Saturn.
Yeah.
And so.
It's a twin brother of yours.
And so what's interesting about Enceladus, and that seems to be the number one place right now for us to go, is because the water is actually at surface level, right?
No. But...
The geysers?
No, but the geysers are. So that's what's in this picture on the upper left-hand corner. So those are the backlit geysers that are coming out of the, I think that's Enceladus, yeah. So you've got these fissures in the ice, and you've got water that's erupting out of these fissures, and emanating from the surface is geysers, and here you can see them backlit by the sun. So we know that the water's there, right? If we can just send a robot over there, have it dig down through a couple miles of ice. It's really thick. But if we could do that, then they could swim around and see what's there.
Nice.
So that's solar system, okay?
So ask your astrophysicist if Enceladus is right for you.
Jesus Christ.
The third pathway opened up just about 20 years ago, just a little over 20 years ago, with the discovery of planets orbiting other stars. So that happened around 1995. Well, it was 1995. I was there when they made the announcement. That's how old I am. And it showed that planets do exist orbiting other stars. And if planets do exist, then the next question is, do planets like Earth exist? And that's where the Kepler mission comes in, that maybe we'll get to talk about a little bit later.
Cool.
So.
Sounds good. Is there another slide on this one as well?
I don't.
Or is there just one
think
on this one?
So.
Just one.
Do you want me to check? I'll just go to the next question. There we
Perfect. We're really excited to get to that part of the Kepler telescope. We're so excited. Or is it just me? Or are you guys excited? Yeah! So I do want to check in real quick and just say hello to the viewers at home. Thank you so much. We are live streaming this event along with Piano Fight. So thank you so much for watching. We'll get a little applause for viewers at home too. Woo! So,
my mom appreciates that.
Well, so we'll move on to the next question. Comedians, so what do you guys think? What information does a star's wobble give us? Wobble, 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 wobble.
Something about a gravitational pull from planets that may or may not be orbiting it.
She's killing
it. Wait,
you
hold on.
Really let anyone else win a prize here? Look at you.
Natasha just stole.
Sorry.
You're just nailing it.
I'm so sorry. Oh, I'm sorry.
You came into the show and you said, just like the rest of us two idiots, that you didn't read anything about this.
I
Then you
did.
went to the bathroom for like 10 minutes.
Listen to
podcasts.
What's going on here? Someone's cheating.
I'm a big
I
fan
see
of
some writing on
podcasts.
your arm. I have no idea
Yeah,
what's
I
going
see
on.
that.
You're
Sorry.
trying to win all the prizes.
Star wobbling.
I'm sorry.
Well, one, I second what she said. It's kind of like wobbling, like it's having trouble crossing Geary or something. It's like.
Well, the stars might wobble, but they won't fall down.
That's true.
What information does a star wobble?
What is a wobble?
I don't know.
Remember the weevils used to wobble, but they won't fall down? They're like stars.
Okay.
Stars will wobble, but they won't fall down. Plus, there's no such thing as down for a star.
I didn't play with weebles, but I did have that punching clown.
The
It's
punching
same
clown.
idea, right?
Yeah.
Yeah, it pops
Right.
back up.
What do you get by
Okay.
punching a sun?
What
She's
do you
deep.
get, Natasha?
Quick fun fact.
What information do you measure?
Quick fun fact, heard from Star Talk and Neil deGrasse Tyson that a lightning bolt is actually hotter than the surface temperature of the sun. Ooh.
Hot take.
Ooh.
Wow.
Okay, so audience, let's see if you guys know about stars wobble. Okay, yes.
Exactly.
Wait.
Exactly.
See, I was.
Wait, what'd he say?
I was gonna make a joke about how much the star drank.
Oh,
and
he
this
did
guy,
right there.
Right,
Yeah, okay, I was about to say
God damn it.
martini. It's nailing
Got
it.
the Tonight Show writers' room in the
Yeah,
front row.
He and I should switch.
You can sit on my lap, sir.
Should I switch with him?
No, you're doing well.
Should I switch with him?
All right, let's go.
Good, actually.
The age of the star from the Doppler, from the wobble, no. No, good guess.
That's how many rings a
Good
star has.
The solar spectra, or the spectra from the star?
There's a spectrum involved, yes.
Hmm.
But what physical property are we measuring? Excitement.
I think you're measuring the Doppler effect as it pulled to and from when a planet rotates around it.
So in the spectrum, you see the Doppler effect. What does the Doppler effect tell us?
It tells us whether it's going in towards us or away.
Yes?
Ooh, twin sun answer.
So a planet is pulling that star towards or away from us, making the star wobble. Yes, give the man a prize. Yes.
Oh, there it is.
Eureka!
Wait,
combination.
So it's the planet's mass.
Yes.
Plus the martini answer, I assume.
Yeah.
Right.
What do we got in there for this fella? Oh yeah. Let's see.
What is
guys.
that? Oh.
Ooh, a little Gouda moon cheese. What do you think? You wanna-
Why is it
ice cream or something?
Why is it not Swiss though?
Cheese?
Oh, you feel that? It's hard in the hand. It has enzymes too,
Hard
apparently.
in the hand. Jesus
Yeah.
Christ.
Just add water, and diarrhea will come.
Hard in the hand.
Someone else got some? Yeah, 2 moon cheeses.
So what was the actual answer? Did anybody else understand it?
Oh,
The mass
okay.
of the-
the mass of the planet.
The mass of the planet.
Okay, so Natasha, did you know?
Yeah.
You know that planets orbit stars.
I do.
Did you know that stars also orbit planets?
Ooh!
What?
So,
Well, mind
so
freak.
are you telling me that Jupiter actually pulls on the star?
It does. The sun is actually orbiting Jupiter, just like Jupiter is orbiting the sun.
What? How much does
Yep.
our star wobble?
Our star wobbles very slowly. Jupiter is very far away, so it doesn't exert a very large tug. It's maybe something like a walking speed. So not very much.
I like how you're demonstrating it.
Yeah.
Do you like that?
Yeah.
So are you Jupiter in this scenario?
No,
Or
I'm
he's
the sun.
You're the sun.
I'm the
Okay.
sun.
And
I
he's
have an
Jupiter?
animation. Can I show it?
Yeah, yeah, of course.
Oh, I have to click or something.
Jupiter takes 10
How do I
years.
click
again.
Earth
Keep
years
clicking.
to orbit the star.
Keep clicking like this? No.
Takes a long time.
Oh. Click one more.
How do
two,
I
two
click?
ahead. Keep going.
Huh?
Keep clicking. You want the wobble?
I want this animation to play.
Oh, I don't know how that animation's gonna play.
Oh no!
Now I
there you
screwed it all
go.
up. Sorry.
Space bar.
Now-
Okay.
What-
You guys fix that. I'm
The
gonna
outer
tell about the Doppler wobble.
I love her. She's just like, I'm the smartest person here. You do that.
You fix this.
You do it, dummy. It doesn't matter.
Yeah, how do stars wobble? You tell me.
Okay, imagine. So there's an animation here that shows two objects orbiting each other
Press
from
the
gravity.
space bar, Clint.
But
Let's see if that works.
let's come up with a better analogy. That's
Okay.
I think it's the
well,
next
let's
one
do the
after
ice
this.
skaters.
Or if
Okay.
you click on it, maybe.
Shh, okay, you can fix it, but be quiet.
It's the third slide. Two more.
Oh my God.
Okay, good for you, but now be quiet.
Is it playing?
I
Still
think
not
it's. I
playing.
think it's ahead though. There is an animation, but you got to go.
All right, so here we've got a star and we've got a planet, and they're orbiting one another in this animation. And in fact, what they do is they orbit around their common center of mass. So imagine that the planet and the star are connected by a rod, and your job is to go there and put your finger where the center of mass would be to balance them, right? It's going to be really close to the star, right? Because that's the big, heavy, massive thing, right? That's the point, that fulcrum point is the point about which they're going to orbit. So the sun orbits a little bit, and the planet orbits a lot because it has a tiny mass. An analogy would be, you can switch slides now for me, thank you. These ice skaters. So you know that game when you go out on the ice and you hold hands and you try and skate in a circle really fast, right? So when the two people are almost equal mass, they will both just spin in a perfect circle, right? But what if it's, I don't know who, like some Tucker.
Oh wow.
And this woman sitting next to him, this beautiful woman sitting next to him, what if they were to go up on the ice and do the same thing? And Tucker's going to be standing almost.
Yeah. Liability.
He's going to be almost standing still, and she's going to be doing all the accelerating, right? So in this way, by seeing how much Tucker moves, we can deduce her mass, right? And that's what we do with planets.
Nice.
Never do that to a lady, just so you know. Good advice.
Never wobble a lady. Okay. Oh, this guy.
Good point.
Whoa, wait. Hey, buddy. Whoa, come on, Professor X. Let's calm down here.
Swipe
you look
left.
good. Why don't you back that mass up?
Hey, girl, why don't you back that mass up?
Why don't you back that mass up?
That girl has some mass on her, man.
Baby, do you
Mass
want
10,
to go
it's free.
ice skating on our first date?
No, I know that trick. I know what you're trying to do.
This is like, wow.
So I think we might actually have one more animation. And before you show it, let me say that with this technique, we can't find today, with today's technology, we can't find planets like Earth. Because Earth is really tiny, so it tugs on its star so weakly that this Doppler motion, this wobbling, would be like not even a walking speed. It'd be like a ladybug crawling on the floor.
Oh, wow.
Right?
Yeah.
Yeah.
When you find an indication from a wobble of a larger planet, which we can detect, do people think in general that there might also be other smaller planets?
Good
like
question.
in our solar system?
Yeah, well, when you measure the velocity back and forth, this wobble, maybe it's not going perfectly around in a circle. Maybe it's like tugged a little this way and then that way and then back because there's multiple planets. And so oftentimes you can see that in the data. You see these velocities that are not, really smooth and perfectly, like we'd say, sinusoidal or in an expected shape. So yeah, we can detect multiple planets that way too.
And so so you said it's just such a small amount,
It's
the
too
ladybug.
small, yeah.
And so how then do we detect?
So fast forward to the Kepler mission. Kepler was NASA's first mission capable of detecting planets as small as Earth. And this was a huge breakthrough. Yeah.
Woo! Yay.
So maybe I could ask an impromptu question.
Absolutely.
I mean, so how does Kepler detect planets? Does anybody know? This
Well,
woman right here?
The right side.
Yeah.
So it looks for transits. So for the little tiny planet passing in front of its star and the light going down.
So we're measuring
the amount of light.
Amount of light or brightness. Yes, Eureka.
Yes. Nailing it. What do we got in here?
Okay, so did you put another?
What are you gonna?
Okay, yeah.
What are you gonna?
All right, 1 second.
What are you gonna give her? $500? What are you
What's
talking
that?
about?
Oh, a free iPhone.
Whoa!
Oh. Look at that.
Now you found Earth of your own.
That's a very
all
appropriate
that mass.
phrase. Yeah.
So I would like to ask Natalie to explain the analogy of the New York City hotel and what Kepler's doing. Yeah.
All right. So here's the thing. We're measuring the brightnesses of stars, right? And we're hoping that in some of these planetary systems, their orbits will be aligned so that the planet passes directly between the star and the telescope, right? That means you're going to see the planet eclipse the star. And so even though you can't see it by taking a picture, you can measure the brightness of the star, and if something passes in front of it, the brightness is going to go down. And if it's a big thing, it's going to go down a lot, and if it's a tiny thing, it's going to go down just a little. And we're looking for these tiny things, these Earth-like planets, Earth-sized planets. And so how difficult is this? Well, I can say that the amount of dimming is like 1 part per 10,000, but that doesn't really tell you very much, right? So the analogy I like to give is to imagine the tallest skyscraper in New York City. Maybe it's like, what these days? I don't know, 80 stories high? Something like that? So it's nighttime, and every window is open and every light is on. So you're staring at this building and you see all these illuminated windows, and you measure that brightness, and then one person in this hotel walks up to the window and lowers the blinds by about 1 centimeter. That's the change in brightness that we have to be able to measure to see a tiny Earth-sized planet eclipse its star.
Yeah.
This is like Rear Window, or this is, you like spying on these planets, what they're doing. They have to lower their shades. So
Do you think they're killing each other?
I think they're probably undressing or having sex, and this is like the whole mission here is just to get some.
Undressing or having sex?
Yeah, I usually have sex while I'm dressed. Why? You're different than me? I don't understand.
What are you taking off your clothes for? I thought we were gonna.
Yeah.
Let's go ahead and have a question.
Yeah. You should want to think about that longer.
Did people here want to have a question? They seem upset.
Oh, that's a great question. I can repeat it, and next time you can be faster. Okay.
Oh, damn.
Oh! Wait, when did this turn into roast battle? This is crazy. Yo, wait. People, you guys don't even know, but behind the stage, she was sweet as Martha Stewart, man. She was like, I don't know what I'm going to say. And now she's just like, your mama. You know what I mean? God dang, man. This is crazy.
Now I forgot what the question
Big
was.
N.
Okay, yes, I know, I remember. How do you distinguish? Go ahead.
How do you distinguish between a planet passing in front of a star and the star's natural variation in energy production?
Yeah, excellent question. Stars, even our sun, is not a constant light source, right? We have sunspots, for example, and they rotate in and out of view. And in fact, one time we put forward this proposal to do this mission to NASA, and they rejected it for that very reason. They said, how are you going to find these things when you have sunspots? So the answer is that the time scale for those spots to go around is like 30 days, on the order of 30 days, right? It's one spin of the sun. These transits that we're looking for, they only last like 4 to 12 hours. And they repeat, once every orbit. So, they repeat very spaced out timescales. So the point is that the signals are very different. The star can be doing all kinds of things on its brightness, but superimposed on that, you have these tiny dips. And so they pop out. You can write computer algorithms that find them.
And then when we can determine that the orbit period is very short, 3 to 30 days, you know that it's a very hot planet.
That's right. So Johannes Kepler in the 1600s taught us that the orbital periods, time between these dimmings of lights, how long it takes the planet to go around once, is related to how far the planet is from the star. So that tells us how much energy the planet is receiving. If you think of the star as like a central campfire or something, and how far you're standing away from it tells you how much energy you're receiving, and whether or not it might be nice and
In the Goldilocks, so... Oh.
What are we going to do with this guy?
I don't know. I think you're going to handle him, though.
Surprise.
It's one of our questions you forgot.
I feel like we're going to get a Yelp review after this show.
That's all your questions.
Man, I don't know much about astrophysics, but I know tension. You know what I mean? God dang,
you need to bring her an apple or
it's
something.
like a bad family reunion.
I need to get faster. I need to remember more. What else? All right, let's go to the next one. So this is an animation. Clint, can you... Yeah. You want to skip it? Okay. The animation just shows the planet going through.
Do what she says.
Nice.
Yeah, so we don't actually take pictures of these planets. All we do is measure brightness. And so this is what we measure, and we're looking for these small dimmings
Sounds like
of light.
standardized testing. I had one of those in my eye once, I think.
So
One of those little floaties.
So Kepler is measuring up to 3,000 light years away?
Yeah, so we're surveying a part of the Milky Way galaxy. It's like a cone going out 3,000 light years, and on the sky it's about the size of my open hand.
Just one hand
Just
of the
one
sky.
hand. In that one hand, there's 4.5 million stars from our galaxy alone, right?
You go.
So is
Yeah, look at your face right now. You're just like, what?
Yeah, I guess I'm stupid. You know what I mean? So like, I'm sorry.
My ego is
I went to
dwarfed.
San Francisco State. This is blowing my mind. You know what I mean? Jesus Christ.
Nature just dwarfs my ego all the time, and that's a
Yeah.
really good way to 4.5 million just in handprint.
Yep.
So Kepler's measuring a few 100,000 of
Yeah,
those
so
solar
Kepler measured the brightnesses of about 170,000 or so stars once every 30 minutes simultaneously, all 170,000 stars, and it did it for 4 years, more or less without blinking, so that we wouldn't miss any. Yeah. Do you want to take a question?
Yeah, let's take a quick question, and then we'll get back to slides, and we'll come back to this.
That's a really excellent question. A few reasons. Oh, sorry. The question is, why did we choose that one handprint, which, by the way, is in the constellations of Cygnus and Lyra, which are visible from the northern hemisphere in the summertime? Okay, so first we wanted a place where there's lots of stars. And where do you have lots of stars?
Outside.
Hollywood, California. I know that one. I watch ye.
You have lots of stars in the plane of the Milky Way galaxy. So I wanted to look close to the plane of the Milky Way galaxy. Okay, so that's one thing. Second thing, we wanted it to be in the northern hemisphere, not the southern hemisphere, because we're going to follow up these observations or these planet discoveries with ground-based telescopes, and our ground-based telescopes are in the northern hemisphere. So that's number two. Number three is we've got this spacecraft orbiting the sun, like so, and it's always pointing in one direction, staring at this one patch of sky, right? So if that patch of sky is... What?
It seems so sad.
It's like North Korea.
Yeah. I was thinking it's like American Tail.
It's
You know, like
persistence.
they're both looking another like satellite, another part of the galaxy. Yes.
Oh, gosh. Here we go. That's a callback.
Okay, none of you liked it, but one person really
no,
enjoyed that bit. So
She totally got it, yeah.
if I could get one of that for each, you know, we'd be doing a.
It's a little bit of a downer.
It's a little bit of a sad. Anyways, sorry to interrupt with my.
So in this orbit, you're going to have a situation where sometimes the spacecraft is pointing over the sun, and you don't want that angle to get too close to the sun. So those three things combined already limited our search to one general area of the sky, and the rest was just optimizing it to see how much science we would get back. For example, if you're trying to see a firefly in front of the San Francisco skyline, that's going to be really difficult. But if you look up just a little bit, you'll still see the fireflies that are nearby you, right? So we didn't want to look exactly in the plane of the Milky Way. We lifted it up a little bit to optimize it.
Yes, and the location of Kepler is in L2, right?
No.
No, where is it?
No, Kepler is in an Earth trailing orbit. So it's kind of like a dog on a
ETO.
leash. It's kind of like a dog on a leash behind the Earth.
Is it L3, L4?
No, it's not at
L7?
a Lagrangian point. No. It's not at a
Oh, no
Lagrangian
prizes
point
for
at
the
all.
host.
No.
It's just
Yeah, the orbital period of Kepler is like 372 days instead of 365. So it's a.
Wait, can I get some breaking news? This gentleman over here said something very important.
Wait.
That's what Natalie was saying, and I was so because it's such a clever thing, the Lagrange points. You know that, so I think we should just acknowledge you for just bringing that into the conversation, even though it was wrong.
It was all.
Yay!
There you go.
Man, it's like Jerry Springer, man. This is crazy,
Yeah.
man. Man, this
Now
is
hug it
somebody
out.
gonna start fighting.
Wait,
This
what
is-
was-
man, I didn't know it was gonna be this lit.
I
This
like
is crazy.
being wrong,
I did
man.
not
What
know.
was the point? What was the
Apparently it's involving a dog leash. Did I get that right?
He's giving him kudos for knowing the Lagrange point.
Lagrange point.
It's a common place to put rockets, or to put spacecraft, I should say.
Oh, it's like a storage closet.
There are special places where gravitational forces kind of balance out. So spacecraft like to hang out there.
So they're home on Lagrange?
But wait, did you have?
She's just killed.
Wait, did you have something?
Kills with the puns.
Wait, I think he had something that.
Yeah. That's right.
More or less.
Exactly.
Thanks for we wanted that amplified.
More or less, that's an equilibrium, right?
And one of those points is really important for future space exploration.
Yeah, absolutely. He's pointing out that a lot of really interesting science is done at these Lagrange points. In fact, you guys have heard of the Hubble Space Telescope, right?
Yeah.
The successor to the Hubble is going to be the James Webb Space Telescope, which doesn't have a nice, catchy name. You guys need to help out with this.
Yeah. Hubble versus Webb.
Well, okay. Webb.
Well, Webb's not bad.
Webb's not too bad.
Catching things.
Yeah.
Boom, figured it out. Thank you.
Thanks. That was easy.
That took 2
Just
seconds.
made someone $1 million. Boom.
Yeah, copyright.
Are they going to call it the Galaxy Wide Web to differentiate it from the World Wide Web?
World Wide Web. Good point. That's right. There's confusion.
He's leaving. Look at him. He's hopping the fence. He's like, I can't take this. I need to be around some smart people. This is ridiculous. I'm going to go to the library.
That's a really good point.
He's going to hang out at Lagrange point and just meditate.
Yeah, no, I think she's right. You can't call it the Web. You guys need to continue consulting here. The James Webb Space Telescope is going to be put at one of these Lagrange points. Yeah, the L2 point.
And it blocks that allows it to block off a majority of our starlight because the Earth eclipses that starlight. And then
I don't think that it always eclipses it. No. But it is a nice thermally stable environment. You don't have a lot of changes from the solar radiation.
one half of it's at like negative 400 degrees Fahrenheit. The other half is at 200 degrees Fahrenheit.
If you get into the sunlight,
yeah. And they have a bunch of shields for the sunlight to make sure it doesn't get overheated on that side.
That's right.
There's a lot of engineering that goes
I mean,
into
the sunlight is also good because it powers the spacecraft.
Are they even talking to us anymore?
No.
We're having our own conversation here.
Let's go back to naming telescopes.
Yeah.
Mine's called the Looky Loo. It's named after Lucy Lou.
So just an idea. Just remember that the next time that you see something that was pulled from a NASA telescope out in space or a satellite, just remember all of the work, like the thousands of people and the thousands of hours that went into getting it there, and all the math and physics that went into getting it there, get the photo, and just if you care about that, fund it, and tell other people to hopefully fund it.
Oh, wow. Is this like for the employee award ceremony?
Wait, did you say moment of silence?
Yeah.
I like she's a badass up there.
We get very emotional about our space facilities. All right, do we have another question?
Yes.
There we go.
All right, comedians. What are hot Jupiters and why are they so easy to spot?
Hot Jupiters? That sounds like something I have to clean up with bleach. You know, if I got drunk and my friends pull a hot Jupiter on me. Is that like a
It
Boston
definitely sounds
steamer?
like something at the gay club.
Yeah.
At the gay club.
I definitely feel
at the
like
nightclub.
I feel like this would be like
Which is
like,
gay.
I feel like this would be like a extension of Girls Gone Wild, like Planets Gone Wild.
Hot Jupiter.
Bunch of hot Jupiters ready for you.
You can tell by the
18.
You can tell by the she's got that dark spot on her.
You see her, man? She's so hot. Such a hot Jupiter. Look at the way she look at
all her mass.
Look at the rings. Look at the mass on her, dude.
Yeah.
Look
She's
at the rings.
massy
She was
and
asking
gassy.
for it,
I
dude.
know.
Look, you see those asteroids around her, dude?
She wants to
They
go
must
ice
have had
skating.
money.
I like how you're doing like a...
All right, let's bring it up here. Somebody that hasn't answered that. Yeah.
Well, we
wait. Let me bring it up.
Oh, this guy looks
Hold on.
rich. Oh my God.
Yeah.
He looked like he
He
invented
could afford
something.
like 10 hot Jupiters in a
Like
penthouse.
Armando Sante is here, man.
It's a planet similar in size to Jupiter, but closer into the sun. So a smaller orbit, and they're so easy to spot for a couple reasons. They cause a wobble, probably a significant wobble, and they block out a whole lot more light. So
Exactly. Very good.
Whoa.
Very good.
Wait, I want to ask. Excuse me, sir. What do you do? What do you do? Excuse, what do you do? Yeah, for.
I come to conferences.
Oh, wow.
Oh, he invented sarcasm. All right. I like that.
What do? I still haven't figured it out.
Oh, roast.
Give
We're
it up.
getting burned.
I think I found my father. Oh my God, this is crazy.
You just
I've
got
been
hot
looking for you, bro.
What are we giving?
You owe me like
Wait, wait.
$80,000 in child support.
Steve, do you want to decide what your new best friend gets? Do you want to pick a prize for him?
Oh yeah, I get to choose this. I get
he
the
gets
prize.
to choose
It's
the
an empty
prize.
coffee cup. Choose what you get now.
That's what you get, Dad.
This guy over here. All right, let me see what you get. All right. Oh,
You just got hot Jupiter.
He's gonna drop a hot Jupiter on you.
Yeah. Okay, let's give him the box with. I know what a telescope is, man. All right.
A looky
Oh,
look.
I'm trying to impress her, all right?
I know.
All right, let's give him the telescope.
Telescope it is.
Yeah. Woo! There you
Looky
go.
Lou.
See, look at that. Look at that. Happy Father's Day. He's like, I have 4 of these.
Well, now you can use it and see us a little more clearly.
So what is the significance of the hot Jupiters?
So he raises some good points. So the hot Jupiters are massive, and they're orbiting very close to their parent star. In fact, it takes the Earth 365 days to go around its sun once. A hot Jupiter typically would take like 3 days. So they're really close. They're like 20, 30 times closer to their star than Mercury is to our own sun. And so this tug that we talked about depends on how massive the world is, right? Jupiters are, of course, the most massive planet in our solar system. But it also depends on how close the planet is to the star. The gravitational force goes up really rapidly as you get closer to the star. So they invoke a really large tug on the star. You can see that as a very clear wobble. And if you're going to use the transit method that we talked about, where you measure brightness, and this planet actually happens to go between the disk of the star and your telescope, it's going to dim a lot of light, right? 1 part per 100. And so have 100 light bulbs take away 1. That's much easier to see, right? So that's why they're so easy to spot. But this is an artist rendering. Again, we don't have actual pictures of these planets. But the very first exoplanet orbiting a normal star was one of these hot Jupiters. It was really crazy because, in our own solar system, we've got all this small stuff inside, close to the star, and we've got all the big gaseous giants outside, really far away. And now here we had a Jupiter-sized planet orbiting much closer than Mercury is to our own solar system. So it completely turned upside down all of our theories of planet formation. We had to go back to the drawing board and figure out how you could even get these things to form in these other planetary systems.
Would that happen in our solar system if Jupiter got too big? Would it just suck up all of us and the other 3 guys?
If all of a sudden Jupiter started spiraling inward, we would all get knocked out of our solar system like little ping pong balls or like little pool balls.
Oh, we'd get knocked out.
We'd probably get knocked out.
We wouldn't get sucked into the Jupiter?
Or sucked into the sun, maybe. Our orbits would be perturbed. And if our orbits are perturbed...
Slightly disturbed orbit.
This bubble is perturbing.
Can you elaborate on that day at NASA when you guys discovered that there are hot Jupiters that have 3-day orbits around stars? It just blew apart everything that we thought in our solar system.
This first discovery wasn't done by NASA. It was actually done by a European team.
Very cool.
Swiss astronomers, yeah. And I was a graduate student at that time. And exoplanets, this word exoplanets, planets orbiting other stars outside our solar system, it wasn't even really in our vocabulary, right? I didn't think about it. I was studying stars, and I went to this conference kind of on a fluke, and it wasn't even a scheduled talk. It wasn't on the agenda. We didn't know that somebody was going to come up and announce the discovery of another planet, and they put it like on the last day, like Friday, very last day at the end. So they made the announcement, and it was almost like, wait, what? Huh? We were just kind of sat there. Nobody really did anything or said anything. It was this huge milestone that would completely change the course of all of our lives, right? I mean, we all started studying different things from that moment on, right? It completely changed the course of my career. But at that moment, we were just like, oh, okay. I mean, it took time for it to sink in, maybe 15 years or so.
By the way, Kasim left to go to the bathroom and cry. His feelings are still hurt. He is perturbed. Oh, thank you, sir. We'll tip you on the way out.
So is this called Dent? Is it any relation to Arthur Dent, or is that just a coincidence?
Yeah?
Okay.
I don't know. You hit
I guess,
something.
yeah.
I don't know the answer.
And is
to the
that why you guys
question.
are giving out Jackie Robinson?
Do you
Because
want to
he was
answer
number
her
42?
question? Oh, well,
He just-
can somebody answer her question?
Oh, okay. So that's just a coincidence with Arthur Dent? Cool. I like my thoughts too. All right, you're welcome.
All right, let's see. So did we have another?
And are those Jackie Robinsons?
All right, now we've got another question for
He was
you.
number 42.
You can look in our little box.
So, where exactly is the Goldilocks zone?
Where
Goldilocks
exactly
zone.
is the Goldilocks
The less
zone?
well-known Golden Earring song.
Golden earring song.
Look at your references.
I'm not familiar with
They
it.
sing that song, Help, I'm someone to the Twilight Zone.
Goldilocks zone. Oh yeah, I don't know that.
Remember Goldilocks? What do you remember from Goldilocks?
I got porridge and no, it's
Yeah,
She
porridge
was
and
at the
bears.
orphanage.
Porridge and bears, that's right.
Yeah, so it's clearly near between the bear zone and the porridge. I'm getting scientific. Stay with me for a moment. Yeah, it's going to be a zone that's kind of hot but not too hot, cold but not too cold,
Soft.
sexy but not too sexy. I'm actually describing myself.
All right, audience.
Did you write that down?
I should.
That was very scientific. I liked that.
Go ahead.
Thank you.
Hold on. Let me come up there. All right.
Distance a planet orbits from its star that is just far enough away, but not so far enough away to where water can exist as a liquid on the surface.
On the surface, exactly.
Oh,
Eureka!
There it is. Eureka. Nailed it.
So
What do we
who's
wanna
the
give-
prize master? Sure.
Should we, yeah, I think, glow in the dark planet system, huh? Whoa. Yeah. You can stick these on your too expensive apartment you probably are able to afford because you're educated and might work in tech.
Not
Might be.
exoplanets, just the regular boring ones.
Are you okay now?
Yeah.
All right.
Yeah.
All right. I told them you went to cry in the bathroom.
Why do you gotta tell everyone my business?
I'm sorry.
So we learned, while you were out, we learned where the Goldilocks zone is.
Man, hey, that's great.
All right, so the Goldilocks zone, as the gentleman said, is where liquid water could potentially pool on the surface of a planet. It's not so cold that the water will all be locked up in ice form, and it's not so hot that it'll all be boiled away. Why do we care about water? Life, right. Why not oxygen or pizza or I don't know. What? I still didn't hear you. Silicon? Oh, you said silicon. Why not silicon? Yeah, I mean, why water? Because it's polar. I mean, life on Earth is really diverse, right? We go to all these exotic places and we find life forms that don't require oxygen. We find life forms that don't require sunlight. We find life forms that feed on really weird things. But the one thing that all these life forms have in common is, well, I was going for DNA, but yeah, they're
morons.
They're carbon-based, right?
Okay, you're going for DNA, but you're leading us all to water. We're like an audience of horses here. You can lead an audience to water, but you can't make them say DNA.
And good night.
And it is done.
Oh my God! I think you found your
I found
a
it
traveling
cool.
show. This is good.
So carbon-based chemistry that creates life, as we know it at least, requires liquid water as the solvent that does all these amazing chemical reactions, like metabolism, because it's polar. Yeah, and carbon has special properties, right? Yeah. So people always ask, aren't there life forms that require something completely different? Yeah, perhaps. But there are special qualities about both carbon and water that make me think, at least, that life might be ubiquitous in its structure in the universe. But you can know where the Goldilocks zone is, but it doesn't necessarily mean that your work is done, right? You still got to work for it. Now, what we do with it is a different story, right? That's just a joke.
That's like your joke.
I guess, yeah. So, is Earth in the two? Yeah, wait till November. We'll find out if we're in the two domes out.
Next question.
Next question. The most common types of planets detected so far are called super Earths. How are they different from Earth?
Well, it can fly. I mean,
yeah. Inflated ego.
I'll be here all night.
Common types is super.
Are they bigger than Earth?
Yeah.
That's a good answer.
That's a good answer.
But that's one answer. How else are they different?
Are they super? Oh, God. Does Kanye West live on any of these planets?
Not that I'm aware.
Do they not have a gridlocked bipartisan system?
Can we get the answer, please?
Yeah, this is just, we're digging a hole. Somebody out here can say that.
Hey, Lindsay, you got an answer? Yeah, you've been quiet all night. What's going on with you? Lindsay's date, you got an answer?
This is actually the first one I don't know.
This is the first
Oh,
one.
date over.
Yeah,
date
me too.
over. First rule of science dates, know everything.
I think he lives on that middle
All right.
two dumb planet.
I have no idea, but I'm wondering if it's something that super Earths have a larger fluctuation. Maybe their days are longer or shorter than Earth, or their years are longer or shorter, or their temperatures fluctuate more than Earth does. But that's
Pops.
Those are great
Come on, man.
Kasim's dad.
Come
has
on,
the
man.
answer.
Make mom
Seems
proud.
sad.
Okay, super Earth has a mass larger than Earth's, but significantly smaller than like the gas giants.
True.
Okay.
Yes, absolutely.
Damn.
That's right.
So how are they different than Earth? They're
How else
That's
are
my
they different?
dad,
Like,
He gets paid to go to conferences.
Fucking, it's great. See? I'm crying right now. You know what I mean? What's all this?
Is it that they orbit closer to a cooler star, so they're still in the Goldilocks zone?
No, not necessarily. Come in all different kinds of orbits. Right? Is it what?
They don't have a moon?
Is it a surface gravity thing? That's really good. I mean, they are more massive. That's certainly true.
Do they not have a moon?
Not necessarily.
What if they just have low self-esteem? We just call them
super Earth
just
to make
so
them
make
feel
them
better. I like it.
Those are the Earths that Nietzsche wrote
All right.
about, I believe.
Well, here's an example of some of the super Earths that we have discovered.
No, she's got
So this planet, Kepler 10c, was called Godzilla Earth because it's both bigger, it's like more than twice the size of Earth, and it's also very, very massive and has a high density. So in this case, we might think of a super Earth as something that's like Earth, but just scaled up. It's like tripling the recipe of Earth or something, you know? It's just really big, like more real estate, right? But then there was this other thing that we discovered, Kepler 138d, which we affectionately called Beer Belly Earth, because it was also much larger in radius, about almost twice the size of Earth, but it was really light. So its density was really low, you know, Beer Belly.
This tells us more about the scientists researching, I think. Let's just call it down here.
So the point is that these things have really diverse compositions. Like some of them are rocky, but some of them have these really thick hydrogen-helium envelopes that make them inflated, low-density things. But what's crazy about it is if you look at all the planets that Kepler has discovered, this is kind of a technical diagram, sorry.
What?
So
How
here-
many planets has Kepler discovered?
Oh, over 4,000.
4,000?
Yeah.
Wow.
Yeah, Kepler has discovered over 4,000 planets. What's that?
Yeah.
What is Pluto thinking about? I think he's
That's
jealous. Yeah.
So I want a quick check-in. Quick check-in with the viewers at home. Thank you so much for viewing. We here are having a great time at the live show. We
In case you
just
couldn't
learned
tell
that
by
Kepler
watching.
has discovered 4,000 planets, anywhere from very small to
From like Mercury,
huge.
Mars-sized, all the way up to giant planets. Yeah. Okay, but can I say what I think is really incredible about this diagram? This is just a bar chart of all the different sizes of planets, of some of the planets that Kepler has found. Those numbers don't add up to 4,000 because I'm looking at just a subsample. But the most common planet known to humanity right now is a kind of planet we don't even have in our solar system. I mean, these brown bars over here are like the small rocky things, right? Mercury, Venus, Earth, Mars. The blue bars are the things like Jupiter, Saturn, Uranus, and Neptune, the large things. But the most common kind of planet that we know about right now is this like gray area in between. And so we loosely call those super Earths. Maybe sub-Neptunes, that's not quite as sexy, right? Super Earths. And we think that they have a very, very different composition than Earth. Most of them are not going to be like rocky things that you stand on. They're going to have hydrogen and helium-rich envelopes. And maybe even, like what happens if you take something kind of like Neptune, maybe a little smaller, has lots of hydrogen and helium around it in an envelope, but then you plunk it down really close to the star. You know, maybe it develops like an entire ocean covering the whole surface of the planet. Maybe there is such a thing as ocean worlds out there amongst these super Earths. So mainly the take-home message here is that their composition is very different.
So there's 50 Shades of Earth.
Yeah.
50 Shades of Earth.
And before you switch to the next one, just remember, as you are living your complex life on this floating rock, there are 381 other Earth-sized floating rocks that we've discovered in handprint. Yeah. So
That's what the graph says.
Question? Yes.
Can we go backwards from what we've determined from this handprint in terms of what's habitable or just in planets in general? How many planets are there in the universe? Can we statistically say?
Yeah, so the question is how many of these Earth-sized planets are potentially habitable in our own galaxy? Yeah, or the universe. I mean, in the universe, yeah. Let's just talk about only our galaxy, right? And I think I can answer that question without giving away the answer to one of the next questions. Basically, that answer turns out to be, well, let's assume that there are 100 billion stars in our own galaxy alone. Let's not even consider other galaxies.
How many zeros is that?
That's 9.
Natasha's
9 plus
taking
2
notes.
more, so that would be 11. 11 zeros.
She's actually scoring, her
1, 2,
puns.
3,
If you want to know
4,
what's
5,
on the piece of paper.
6.
You're calling me on my bit.
That's only 6.
I know.
Keep going.
Didn't
You're
really want to
running
do
out of
this.
space.
You're a special Earth, Natasha.
So of the 100 billion Earth-sized planets that are potentially habitable, that ends up tallying up to over 10 billion such worlds in our galaxy alone. Yeah, so some tens of billions. I'm sorry? Yeah. I mean, if you look up in the sky right now, Kepler has taught us that when you look up in the sky, every pinpoint of light that you see is actually a planetary system. Yeah, at least one planet per star out in the galaxy. Ooh, good question.
Why hasn't other life found us if there's so many billion other Earths?
Yeah, other life.
Yeah, other life. Get on the ball.
Idiots.
Why is it always about you? Why do we have to look
This
for
is the
you?
Fermi paradox, right? This was posited some decades ago by Enrico Fermi. If the galaxy is so littered with life, then where is everybody? I don't have the answer to that question, of course. But there's lots of different things you can come up with, like maybe they don't want to find us. Maybe they don't want us to know that they're out there. Maybe life just got started in the galaxy. Maybe we're young life. Maybe the panacea of life is like somewhere in the future, right? I mean, there's all kinds of things you could posit.
You
or
think
maybe
we might be getting Star Trekked?
Might be getting what?
Star Trekked?
Star Trekked?
Yeah, like there's a group of people that are afraid to interact with us because they don't want to.
Yeah, the prime directive, yes, exactly.
I call it we're getting Star Trekked.
Getting Star Trekked.
Can we do a quick hand
Hot
raise, a
Jupiters and
poll
Star
of the
Trek.
audience? How many of you guys believe that there is another species that could potentially be watching us? Or wow, that's
Look at this.
That could
Whoa.
potentially, yeah. Wow, that's.
You guys aren't raising your hands?
And
I
those,
love you right there. You just did it like real tiny, like my friends might be here. You know.
There you go.
I think Kepler has made it cool to believe in aliens.
Yeah.
Maybe not aliens visiting us, but life out there, yes, absolutely. All right, where am I pointing this thing? Okay, next question.
Astronomers have found planets that may be suitable for life, but have also found planets that are inhospitable.
What makes the latter so unpleasant?
This is like cosmic gentrification where you just can't deal with it. It's just unpleasant.
There wasn't a Starbucks. You know,
Wasn't, like there's no Whole Foods on my
last
Super
Howard
Earth.
Johnson's
bougie
clothes.
signs just like.
Oh, I was waiting for the.
That's funny. You come on now. That was.
Yeah.
That was good.
Okay. Yeah.
There's lots of reasons why they could be inhospitable, too hot. There's no surface, which we can assume, guess that might be important.
Good one.
They're so far out it's too cold. They're too massive that their gravity at the surface would be too high. Then that's an assumption, but yeah, lots of reasons.
I think that's a Eureka
All
moment.
right, Eureka.
Man.
Maybe they just have attitude problems.
Look at you,
What
man.
are we getting this guy?
Look at you. You guys are just killing it with the prizes.
I think maybe we give him
sign
like
up.
a little family of aliens.
Now wait, give them some for the kids. You know what I mean? These two obviously should get married, have like a bunch of kids.
They should. Oh, you got little
Excellent.
aliens.
You gave them 2 or 1?
All
We gave
right, so
him 4.
some examples of actual things that we have found. We've planets who have oceans made of lava. That would be a downer.
Oh, so that's
right?
a problem?
The planet is disintegrating. We see that happening. Yes,
Well,
planets
I
that
mean-
are breaking apart and being photoevaporated. It orbits a dead star. That happens. Pulsar planets. Or about to be ejected, as we've already talked about, right? Gravitational instabilities.
That hot Jupiter mess.
Yeah, that's right.
We got to eject that hot Jupiter.
This planet is orbiting in a system of 3 stars, gravitationally unstable. It's probably going to be ejected at some point. Yeah.
What happens when a planet gets ejected? It just floats
It
out?
just hangs out?
Yeah, these are called rogue planets.
Does it turn into an
It's
asteroid?
like the
or-
Tenderloin.
Just like
You're walking
hangs out.
around.
Astronomers actually find these things, and they think that there might be twice as many of those as there are planets bound to their stars.
Whoa. You mean 20 billion?
Did you get your zeros right?
She's giving herself a point for that.
There are planets that are on a crash course. For instance, Pluto is it has a orbit that goes straight through most other planets in our solar system. So that's on a crash course. It's eventually going to crash.
Planets in eccentric orbits, yeah. As an example of something that might be inhospitable, yeah. Imagine if you were on a planet where some portion of the year you zoom really close to the star, and then other portions of the year you're really, really far away. That would be difficult. Talk about seasons, right? It'd be really difficult for life to be stable there, I would think. Yeah, good point. All right, let's see. Where is the nearest potentially habitable planet likely to be?
Yeah.
Did I
We
say
can't say
planet?
Earth? That's
Can I
a-
say exoplanet? Yeah.
Exoplanet.
What do you guys
nearest
think?
potentially
So I already
habitable.
told you that there's like 10 billion
There's
of these
10 billion,
things,
so
right?
it's going to be an easy
out of
answer.
like 100 billion. Out
Right.
of 100 billion.
With the nearest potentially.
I guess in that handprint you were mentioning earlier?
I don't know. Can we check Craigslist for this kind of stuff? Is this something?
Situations wanted?
Yeah, situation. Habitable planet is wanted. I saw you
Is
on
it called
Bard.
Earth 2?
It'd be a good name.
Is that a show? Oh.
Alpha Centauri Proxima b.
Proxima b, that's
Oh.
right.
You said that like a pimp. He just, boom. Holy
and
stuff.
how far away is that? Natalie?
Proxima b is only 4.2 light years away, so it's just a stone's toss, a stone's throw. Now, Kepler was launched in order to determine how common these kinds of planets are, right? So, what's that? What's a light year? It's a distance that it takes light to travel in 1 year's time. We cannot travel faster than the speed of
know.
light, but but engineers think that we can get to like 20% the speed of light. So if you can go 20% the speed of light, I mean, Alpha Centauri, Proxima Centauri, you're talking, a couple decades.
It's enough to get you laid, man. Don't
Now,
worry.
when you convert that to parsecs, how does that work out?
Quickly, let's have Natalie do the analogy.
If the Milky Way was the continental United States, how
Yeah,
close would
okay. So here's the question. I mean, Kepler was launched to determine the fraction of stars that harbor potentially habitable Earth-sized planets, right? So we find these planets, and now we have to convert it to actually what's out there. We have to say, okay, here's what I discovered. So what does that mean about how many are actually out there? And so we learned what that number is, and we can do an analogy. We can say, let's take the Milky Way galaxy and let's scale it, let's shrink it to the size of the continental United States, right? And so we're here in San Francisco, kind of on the shore of the Pacific, and so we're standing on the West Coast, and we turn around and we look across the continental United States, and you ask yourself, where is the nearest potentially habitable planet likely to be? And the answer turns out to be like in the shoe department at Macy's, right here at Union Square. I mean, it's really close. It's like a quarter of a mile away, or within about 10 light years. And then, yes, lo and behold, astronomers found one of these planets orbiting Proxima b, the very closest star.
The shoe department.
Okay,
Essentially the answer.
That view is actually from the Starbucks in Macy's. Just.
Oh, is it? Okay. I stand corrected.
Yeah, so that's blows my mind as well that it's that close across the continent.
So these things are really common. And I think that that really changes the way we think about space exploration and our ability to find evidence of life beyond Earth. So, you know, finding evidence of life is tangible. It's a tangible goal. We know how to do it. We just need the resources to do it. It's like something that could be done within the next 30 years. I think it would be amazing to be able to look up in the sky and point to a star and say that star is harboring a planet that has life. That's really paradigm changing.
Can I ask a question?
Yes,
I always wonder, like, when people talk about life on other planets, like the same for yourself. Is there a vision that you have, like what this life would look like?
No. I mean, I'm not getting too spun up about what life is going to actually be, except to say that it's probably going to be carbon-based and it's going to have some kind of byproduct. You know, we're going to detect the byproducts of that life, like maybe oxygen or something, you know, from photosynthesis, or, you know, cows farting out methane or something. I don't know.
Farting aliens would be cool.
Farting aliens.
That's how the first one's like, yeah, it was the fart.
Yeah.
That was.
Okay, do we have more questions here?
The big fart theory?
The big fart theory. Bazinga.
Why can't ask?
We can, sure.
That'd be great. So, let's just go ahead and have Natalie speak about the coronagraph, which is.
Yeah, unfortunately, I didn't bring the animation, but the question was going to be, why can't astronomers actually get a photo of an exoplanet? And basically, it's akin to trying and see a firefly next to a lighthouse, right? I mean, the star itself is like 10 billion times brighter than the planet that you're trying to take a picture of, right? So it's literally lost in the glare of the star. So this is a huge technical challenge, right? How are we going to do this? And the answer is actually really elegant and simple. It's the same thing that you're going to do if you go out in front of your house at night and you want to see the stars, but you've got all these street lights in front of you. What do? You just like block out the street light, right? And you can see the stars behind it. And so it's the same idea. We want to build a telescope that actually blocks out the light of the star, thereby revealing the faint things next to it.
So it's a separate part of the telescope that launches this. It goes 10,000 kilometers away from the telescope, and then it just opens up enormously to block out all of that star's light, and then we just take the light around it to find the planet.
Yeah, that methodology is called a star shade. It's literally like putting a thumb up in the sky, except it's this big other spacecraft. It's shaped like a sunflower because it controls very precisely how light bends around the object. So that's called a star shade. Alternatively, you can put a tiny disk inside the optical path of your telescope, and that's called a coronagraph.
Yeah, I think we just heard it first, alien.
It's happening! It's happening! I knew it's the government!
Yeah. That's actually, that microphone's made from alien technology. Can you like hit it, the microphone? That's
Boy, we can talk about astrophysics. We can't get a mic that works.
Yeah.
Today's mic was sponsored by Radio Shack.
Yeah.
Hello, okay.
Yeah.
Okay, so you guys already brought up, oh, no. This is a different question. Okay, so how are we going to find life? Well, these future missions that we're talking about are going to analyze the chemistry of an exoplanet atmosphere. So which gases might be strong indicators of life?
Gases? Well, I know my gas does not bring life. Let me think. These guys already know. Look at this.
No, he already yelled it out, man.
Well, okay,
give it
so
up to him.
water
He said it so
vapor.
angrily. He's like,
Oxygen, what else? Methane.
I was going to say
Carbon
that, but I got yelled at for
dioxide.
saying the right answer last time.
I would love to.
These are all great answers.
you get a toy. You get a toy. You get a toy. He's like Science Oprah. Look at this.
Look at this.
Jesus Christ. Everyone, look under your seat.
Wait, did somebody?
Oh my God.
Did somebody say McDonald's
Where's
farts
the
yet?
T-shirt shooter, man? Jesus.
McDonald's farts.
McDonald's
All
farts?
right,
Is that a
so
thing?
they came up with great answers. Methane, of course, is produced by cows.
It wasn't me.
We know, to be fair, I think I read that
It's
cows
something with
actually
me.
burp more than they fart. I don't know if that's true. So methane, oxygen is a big one. This is actually a picture of cyanobacteria, which were the first life forms on Earth. And as they metabolize, they actually put out oxygen. And so here this is cyanobacteria, this algae, and it's burping out a little bubble of oxygen, and that's what gave Earth's atmosphere its oxygen that enabled the evolution of mammals. So what even better is to have both of those things together, because methane and oxygen actually react pretty violently. They produce water and carbon dioxide. So they don't coexist in equilibrium in an atmosphere. If you see both of them, it means you have cows continuously farting and trees continuously photosynthesizing. So that would be really interesting. So what we want to do is we want to catch light that's passing through.
Is it? Let's try it. We'll play. Test it. You want to test it again?
Okay, so we want to
Here,
catch
share with you.
light
I know, I'm
that
not.
has either filtered through an atmosphere of a planet or maybe bounced off the surface of a planet and passed through the atmosphere that way. Because when light passes through the atmosphere, that atmosphere leaves a fingerprint of sorts on the light. So we catch the light, we spread it out into a rainbow, a spectrum, and we look for certain features in that rainbow, right? And that's what's represented here. This is a graphical representation of a rainbow. It's just basically a measurement of how much light you're getting at all the different colors. And so it oscillates up and down depending on what fingerprints are there, what spectral indicators are there. And there could be things like what we call the red edge that shows the reflectance of plant life. It could be oxygen or ozone. It could be carbon dioxide. Seasonal variations of carbon dioxide as plant life flourishes or waxes and wanes for the seasons, through the seasons. All of these things would be indications that that world is a living world in a global way, right? That life has actually taken over that world in a very global way. It's not just hiding in niches. It's more like planet Earth, where life kind of took hold explosively and ignited and covered the planet. So that's the way that we are going to search for life on other exoplanets.
Could we send out like cows, farting cows to colonize a planet and just, save us some trouble?
You would think that we would want to do that, but
Do I
yet
have
there's like hundreds of thousands of people who signed up to go to Mars, right? So, which I think is kind of amazing. Dinosaurs.
Like, are dinosaurs a possibility to find, like on these other places?
That's a great question. Right. I mean, on planets.
You know what? That was the best question. That if you were at a house party right now and everyone's smoking weed, their minds like, "What the fuck, man?
Mine.
This is
blown.
crazy. Give me some chips." You know what I mean?
Here, Natasha.
This is great. Oh man.
Thanks so much. Is it on? Is it on? Yes. Okay. All right. So should we keep going? I think that this is the last question. So you guys brought up Proxima b, this planet that's potentially habitable and so
Proxima
close.
b?
Proxima b is the Earth-sized, potentially habitable planet orbiting the closest star.
Well, first of all, wait, what happened to Proxima A? Is that...
Yeah, that's actually a problem. I've always had an issue with
Have you
that.
had...
Proxima A, I guess, would be the star itself.
Oh, okay.
There is no planet that gets labeled A. And
Really?
That's always bugged
That's
me.
only in Canada.
Yeah. So the first planet that's...
Oh, zinger.
Yeah, so the planets are given little lowercase
Really?
letters.
Okay. And
Yeah.
the stars get the A's.
So if you have like binary star systems, two stars orbiting one another, which happens, in fact, half of the pinpoints of light that you see up in the sky are actually these multiple star systems.
All right.
They're given uppercase letters, like A and B. Like the brightest star would be A.
She's your
The
sound
fainter
right
one
now.
would be B.
Don't
right?
break focus.
I'm doing the theme
Trying.
from when Luke's looking at the two stars. Never mind. You guys ever
Yeah,
see
yeah, yes,
there's a TV
yes.
movie called Star Wars? I don't know if you
Tatooine.
guys.
Tatooine is a
Yeah.
planet. Yeah.
It's a rough
Give
crowd.
it a name.
Okay,
They
sorry,
don't know Star
Alan's
Wars.
keeping us
I
on
know.
track here.
These
So,
are- these
so
aren't
how
science
the
people.
question is, how is this planet different than Earth? Different star, yes. Well, first of all, let's look at the artist's
Whoa.
depiction of this planet. Again, we don't have pictures of this planet, right?
That's a
So we
lot
have
more-
to imagine what it might look like.
Jesus Christ.
Also, your cover photo on Facebook.
It is my cover photo on
A lot
Facebook.
more rock
yeah.
climbing options on
Can
this
you guys
planet.
see that there's actually two? Do you see this right here? Can you tell? Those are the other two stars. So the Alpha Centauri system is actually three stars. A star like our sun, a G-type star, one that's a little tinier, it's called a K-type star, and Proxima is actually an M-type star, that's this one here, and that's a very low-massed star. So there's three stars. This planet is orbiting Proxima, and way off in the distance are these other two. All right? Okay, so here's kind of a little gallery of different star types, right?
Wow.
So Proxima, so a star like our sun is going to be one of these orangish stars. Proxima is this tiny little reddish star. So it's about 8 times less massive than our own sun. It's really puny. It's a really tiny star. So that's one difference. And that means that it's not emitting a lot of light. So if you want to get to the Goldilocks zone, you have to kind of cozy up next to it, right? In order to get enough energy. So that's one thing. Because it orbits so close, it has to orbit so close in order to be in this Goldilocks zone. The gravitational forces it feels are very large, and it has very high tidal forces, which means it could get locked into a tidally locked orbit, kind of like our moon is to Earth, where we look up at the moon and we always see the same face facing us. So that probably happens on this planet as well, which means one side is always going to be in sunlight and the other side is always going to be in darkness. So that's a little challenging, I think, for life, but not impossible, they tell us.
Yeah, that white little dude's doing fine.
That guy's
Dude, he's surfing on that thing. Jesus. I'm getting nauseous right now. This is the best the illustrator could do.
That's right. Another difference on this system is because it's this tiny, what we call an M-type star, these stars have really strong magnetic fields. And when you have strong magnetic fields, you get like sunspots and flares and all these coronal mass ejections, and that pumps out a lot of UV radiation and charged particles that'll come streaming towards the planet. The radiation can alter the chemistry of the upper atmosphere. It can break apart ozone. So that's not very good for life. It can change the chemistry of your atmosphere significantly. And if the planet doesn't have a strong magnetic field, that might also be a problem because you've got all these charged particles streaming towards it, and you don't have that magnetic field to shield you. Astronomers think that it could have a magnetic field even though it's not rotating rapidly. Usually that's what we think of as being required for generating a magnetic field. So there's lots of things to worry about, but the theoretical models that people are doing to explain this planet are actually looking pretty optimistic, that it's not just a non-starter. It actually could potentially harbor life. So I think that gives us a lot of motivation, especially if we can do it in like 20, 30, 40 years' time, to send some robot there to take a picture, right? Why not?
Are you mostly for just robots going and not sending humans?
I mean, I personally think at first we should just send like our cell phone there, right?
Sure,
And take
yeah.
a picture.
Or Matt Damon. I mean, we can just do that because he would love to do a sequel. That Bourne thing was horrible. You know what I mean? It's like-
Matt Damon with an iPhone. I
yeah,
think.
why don't we just sell an actor? Just send an actor up there. You're just gonna make the greatest role ever. You know
Be
what
the
I mean?
greatest
I
documentary.
like the
that's
Siri on
right.
serious action. I think that's
We'll
good.
come back. We'll come back to. Okay, go ahead.
What's that?
Go ahead.
Oh, good point. Killer things on the planet.
Good one, good one.
Yeah.
Okay, I think that's it. Yeah. So
Terminator.
So,
Ooh,
I would
thank you. Where does that orbit?
So on our, I want to ask a quick question.
Did you?
Now we
I
had
did.
some
Okay.
conversation
Oh,
about
like that.
potentially other species on other flying rocks being smart, having advanced further than us, and how being likely that we believe even that there are multiplanetary species. Now, what are your thoughts? Because this is hilarious. Elon Musk and Kimball Musk have actually banned this conversation from their hot tub. They banned
the conversation about
They banned
life?
the conversation about simulation.
Okay, now I
from
hate
their
this.
hot tub. It's hilarious.
Simulation.
Yeah. So I want to ask you.
I was banned
I want to
too.
ask you with a supreme with a
Is
super
their hot tub nicknamed the Hot Jupiter?
with an extremely intelligent species that
It's like a
has
C
that
class.
has figured out how to potentially create a simulation and then see where it goes. Could we be in that simulation?
we be part of a simulation? Oh man, I don't know. I think I'd be out of a job.
That actually leads to my next question, which is
He's like revenge.
Yeah, exactly. It's a comeback.
So my next question. So your simulations kind of you're ambivalent about that.
About us being somebody in a dream? Is that
Are we
like
jumping
the
into the
kind of
Matrix now?
being part of a dream?
Yeah.
Kepler was not fun to find that out. I don't know. I think that the universe is much more mysterious than we realize. I think reality is always much more fantastical than we can imagine. So I do not discount any possibility.
I have a similar question. Do you think that Barb is okay in the Upside Down?
I'm sorry, what? Bart or Barbie? What did you say?
Have you seen Stranger Things?
No.
Spoiler alert, don't screw it up.
And so the follow-up to the
I'm that
question,
guy.
that you said about potentially being, you would have a job if it was a simulation. So I'd like to poll the audience really quickly. If NASA had a position for an assistant scientist on the Kepler mission, who would, if you were given the job, who would quit their job and go work at NASA right now?
Sure, why not?
Yeah, sure.
You mean like just any job?
I mean,
Like,
that's-
you mean like in the kitchen or something?
That's
Or what do
pretty
you mean
big.
by-
No, as an assistant.
Hey
as an
man, I can
assistant.
fry.
As an
you know?
assistant scientist on like the
Is
Kepler
there
mission.
math involved?
So-
Are you looking
there
for work
math
after the
involved?
show?
There's probably math involved,
Is there
yes.
math? Yeah.
I just find it very interesting that 50% of people would. That's a testament to your work, what you
Yeah,
do
yeah, yeah.
for life, that people love.
Well,
find it interesting.
I went to college. I wasn't planning on being a scientist.
What were your
But-
plans?
Well, what were you gonna be?
Gosh. Well, I didn't know. I was just a kid, but I
Were
was
you
a kid.
gonna be
I was
a
majoring in
model?
business of all things.
Oh, okay.
But what really changed it for me was when I had this experience of doing research for the first time, and I was at the computer doing, like math stuff, and just, on the computer and looking
Getting all
at
those zeros
looking
written?
at data, all those zeros, right, writing them down one after another.
Wow. I'm already
I'm
excited
joking,
right
I'm
now.
joking. But the professor looked at me and he said, Natalie, nobody else in the world has seen what you're seeing right now. You're seeing something for the very first time that no other human being knows.
Yes.
That was a tremendous
Yes.
feeling.
How
like,
many times
wow.
have I said that before?
Yeah. I said at approximately 2 a.m. to my Tinder date. No one's seen this and survived.
I'm taking my clothes off this
is
time.
unparalleled to be one of the first people that discovers a new
Just a couple
potentially
lines.
That is pretty
a
amazing.
planet that harbors life, and being one of the first people to discover that on your mission is very beautiful. I would like to ask just one other thing, and then I'll open up the audience for questions.
It's gonna get real.
I know. We have to
It's gonna get really real.
look through his homework.
So this question has to do with something that I'm working on right now. I'm writing a book called Mars Race, and in that book, there's several countries that are launching. It's at 15 years in the future. Several countries are launching. The United States, China, Russia are launching to Mars to habitate, to start habitats on it. And the question is. So in the novel, I'm saying that
Looking
we're
hasn't
sending
written.
people. We're sending people there to procreate. What will be how does that impact a child's life when they're born on a different planet?
Are we in the simulation still? 'Cause I would like to opt out
I think he wants us to write his
now.
book for him.
Wait, but first of all, I love that you plugged your book.
Yeah, a book you've not written.
I'll be selling them in the hallway. Just to let you know.
Soon after that, I'll be writing it.
You're looking for a good plot line?
More so, like what is the actual math behind what would it be like? Because it's a 680 or some day orbit time, like twice the length of Earth's. How does that plus the gravitational pull, which is what, like 60% of Earth's or something like that?
Surface gravity is certainly lower.
So how does that impact humans that live there? Because that's 15 years down the line. Whether or not we want to sit here and say it's not going to happen, no, it's going to happen.
Yeah.
And so it's just interesting to talk about it.
You mean the book you're writing?
No, he's saying that humans are going to colonize Mars one day. I
Right.
think that that's true. I think that's probably right. And there will be biological implications for life here. And I hope that we have technical solutions for those things. I mean, isn't that why we have people on the International Space Station, for example?
Exactly.
Yeah. So
Yeah.
we're preparing for that moment, right?
Yeah, there's a funny thing called an escapee on the ISS, which is when they're taking a poo, and guess what? The poo starts flying out into an ISS, and they're like,
Thank you for that visual. That's great.
Marshall, is that
Will
yours?
this be in the book?
No, but that's part of the testing that they do on the ISS.
I don't think that shit flies in the show.
That's the
Your
closer.
headliner, people. Your headliner.
That's the
Catch up the
closer.
punchline October 19th.
Yeah, some hot Jupiter action.
It's very interesting to talk about that because it will be people that we are watching in 15 years that are going to be there habitating from different parts of the world. And yeah, there's a lot of really cool
Oh
things.
God,
that
that's
come
so
out of that.
scary.
It is scary, yeah.
It's
really
like
cool.
the douchebags living on other planets. You know what I mean? Douchebags
Marine.
/ harsh aliens. You know, it's like, oh God.
Cool. I want to open up. Let's open up for a few questions. We don't have too much time. Maybe just there's going to be lots of time afterward. We have the lobby to talk in. I'm sure we'll stick around. We'll get to know one another. I want somebody has not raised their hand the entire. Okay.
Phil Donahue.
Thank you.
I'd stay up there.
I know we kind of talked a little bit about a disintegrating planet and bringing your New York analogy back into it. Is the quote-unquote alien megastructure, is the disintegrating planet our best explanation of the alien megastructure that was discovered a little while ago? Or is that just a Brooklyn party gone really bad?
Okay,
alien-
so not everybody
Alien
might be
megastructure.
aware of the.
Yeah.
Okay, so there's a star that Kepler has been monitoring, measuring these brightness measurements, taking these brightness measurements, and it undergoes very odd fluctuations in brightness. It almost looks like something transited it, right? But then it happens again, and it doesn't happen really periodically, so it can't be something that's in a gravitational orbit, or at least not one that's predictable in a predictable way. Also, the amount of dimming changes with time, and so it's very perplexing. We don't know what this is. And so people have suggested various explanations for, and one of them is that there's a lot of debris, like maybe cometary debris or some kind of a disk of debris around it, and so that periodically kind of dims the light as well. The problem is that that kind of debris would also radiate in the infrared, and we don't see that radiation coming off of it in the infrared, so it doesn't seem to be explained by debris, which only deepens the mystery, right? So it's called an alien megastructure because one of the proposals is that there's some kind of a structure, engineering structure around it in order to capture energy from the star kind of and use that for the civilizations that live there. So something that's like man-made or alien-made is the proposal. There's no evidence of that, right? I mean, we don't know. When we don't understand something, we like to say it's aliens. But the reality is that we don't know, and there's probably a logical explanation. We just haven't found it yet. But it is very mysterious.
Do you believe in the alien infrastructure?
Do I believe in the alien megastructure?
Megastructure, sorry,
I
infrastructure.
think that's the least likely answer. I suspect that we're going to find a reasonable explanation for the behavior that we see.
That's a pity.
So no.
Other people that
Probably
have not
It would
asked.
be very
yes.
unlikely, yeah.
Do terrestrial biologists have a good idea how life arose on Earth?
No. No, there are many mysteries about the origin of life on Earth. We do not understand it very well. We can take it back pretty far, but we don't understand it. We don't have a clear origin source. So. And, you know, I was brought up thinking that life started in the oceans, like down at the thermal vents or something. And so I was really surprised to hear from an evolutionary biologist that now they're thinking that life started in the shallow pools. Where you've got interfaces between atmosphere, water, and rock. That makes a really interesting chemistry. It's probably harder to start deep down in the ocean. And then maybe that life in the shallow pools then went into the ocean before it then later came out on land.
It's so quiet in here, my God.
So I was wondering back at the way that the Kepler satellite is looking for planets out there. You're saying that it's looking for a planet to come across the disk of the sun?
Yeah.
And I was wondering, do we have an idea of how many planets are rotating at a 90-degree angle that you wouldn't even be able to detect?
Yeah, absolutely. That's a great question. You know, so we're looking for this chance alignment that the planetary orbits are inclined so that they're casting a shadow that sweeps across your telescope, right? And you perceive that as this dimming of light. But for every one that you find, there are hundreds out there that we didn't see because they're all tilted at other angles and they don't eclipse. And so we can actually calculate that directly. There are mathematics that you can write down in order to back out for every one that you see how many others are out. So when I came up with this number that there's over 10 billion planets that are potentially habitable in our galaxy, I have to do that exact correction. So yeah, that's a really good question.
There he goes.
At what point do the planets that Kepler has found are going to be given common names? Do you have a name, and are you taking suggestions?
Oh, sweet.
My suggestion, I love the name Persephone.
Oh.
Was that next girlfriend?
That's a lovely name.
No, I wished.
That's a lovely name. I like it. So the International Astronomical Union is already started an effort to begin naming exoplanets that have been discovered. And I think they're starting with the very first discoveries and working their way up. So they haven't gotten to the Kepler discoveries yet. I don't know what they're going to do once they do. I mean, there's thousands, billions, millions, billions of planets in the galaxy. I don't know if we're going to actually name all of them. There are so many that it's convenient to just give them these numeric designators. But that is the plan, is that one day they will all get names. I personally think they should not get special names until we know something more about them. I think that they all need personalities before we name them.
Well, they have to earn it before they're
They have
called
to earn
Chad.
it. Yep.
I like that, yeah.
Yeah.
All right, who hasn't asked?
One in the front.
Are there any like evolutionary indicators that say we're ready to go colonize other planets, or that like we're of the right mindset to go do so?
God, I wish. If anything, sometimes I think the opposite. You're not talking about, you're talking about sociological issues, you're not talking about technological issues, right? I kind of think that we don't need to overthink it, because once we get the capability, the search, the exploration that it requires, the engineering that it requires is going to fundamentally change who we are. You know, every discovery that we make, I believe, increases empathy on planet Earth. I really believe that. You know, when I was a student and I learned that, yes. I mean, when the astronauts, go ahead and clap, come on, guys.
Clap it up, guys. Hey, come on now.
I can't.
Everyone's drunk now. They're just like, I don't know.
My left arm is
Every discovery leads to a greater sense of empathy.
Yes, when the astronauts went to the moon, and on the way they turned around and they took a picture of a planet that had no borders, that increased empathy on planet Earth, right? When I learned as a student that the cells in my body were manufactured in the cores of stars, all of a sudden I felt not only a connection with every human on this planet, but every living thing on this planet, right? That increases empathy.
So can we like colonize with empathy? Like find some aliens and say, we're not going to kill you, we're just going to hug you?
Yeah, exactly.
You know?
That's why when people say, we should be afraid of aliens and we shouldn't go out looking for them because they might find us and they might hurt us, I don't know. I think by the time we get that capability, we will have enough empathy to know what to do.
Beautifully said. Yeah, beautiful.
Wow.
Man,
There we go.
That was good.
Wow. I think you should run a mega church. You know, like a space mega church.
An alien mega church structure.
Like Christ said.
A ring around the sun.
So good news is that the event in the lobby is going a tad long, so we have a little more time for questions inside.
That was like a high note to end on, I'm just saying.
Yeah, it was a
I don't know if I can top that.
She's basically, you should listen to her.
Duet. You know, this is so great.
You're like, my work here is done, Mike.
But can I ask you a question? Like, when you retire, which hopefully is not for a long time, what do you want your legacy to be? What do you want to accomplish?
I don't think about leaving a legacy. I just want to be a part of the chain, you know. I just want to make the world a better place.
Jesus Christ,
Yeah,
man.
look at this.
Let's lay some water out right now so you can walk right over here and get. God, Jesus, it's like a Jaden Smith tweet. You know what I mean? it's like magical, man.
Smoke and science, baby.
I think you're from another planet. I think that's what I think.
Smart people are better than us, Kasim.
I read that. That's a Snapple fact. That thing right there. I know.
Quickly want to say thank you again to the viewers at home that are watching today. We are all on the same flying rock, and therefore we should have a sense of empathy for one another and for scientific discovery.
Too sweet.
Oh, look at that one. He's like, look at him. He is lifting the notes right there.
Rising tide floats all boats all the time. Yes, let's go right here.
A rising tide floats all boats.
Hi. If you
my
find an
new album.
exoplanet with a lot of carbon dioxide, how do you know it's not just another Venus? You
Yeah.
were talking about carbon dioxide as a
Right.
sign of life. Same with methane. Like if you find methane, how do you know it's not another Neptune or Uranus?
That's a really good question. So for all of these different molecules that we are analyzing, we have to consider both geological sources and biological sources. And then we have to take a look at the context in which they exist. We need to know what kind of planet it is, what its surface gravity is, what its geology might be like, how much energy it's receiving from the star, what kind of energy it's receiving from the star. So all of these things, there's like not one smoking gun that's going to save life. You have to, we call these things biosignatures, like finding oxygen, but it's not going to be like that. It's going to be like a bunch of biohints, and they have to all add up and tell a cohesive story. So I think that's what it's going to end up to be like.
But the Loch Ness Monster's on Enceladus.
But
Yeah.
I'm definitely looking for Loch Ness. Yeah.
All right. Anybody else hasn't asked? I don't think you've asked. And neither have you. We'll make sure to get you guys.
So, say you find a planet 10 light years away.
what's the next step? Do you send something simple like you talked about to take a picture and gather more information, which will come back in 10 years? Or do you spend more money with the chance that you won't find anything, but if you do find something, you'll have a robot or something that can get even more information?
Yeah.
How do you make that decision?
Great question. First of all, there's NASA's path forward, and then there's like everything else. NASA has a very metered path forward for finding evidence of life, understanding the statistics of it, where it exists, and looking at the diversity and all that kind of stuff, all these biosignatures we've talked about. And that path stretches forward, decades into the future. But the thing is, just by way of knowing that planets exist, it's really changing the landscape. So now you've got the private sector involved. You've got like Breakthrough Starshot, right? You've got this philanthropist, Yuri Milner, who wants to invest money to now actually go to Alpha Centauri. And he wanted to do that before we even knew about Proxima b, right? Just knowing that planets were so common, he's like figuring, well, there's 3 stars in the Alpha Centauri system, so chances are that one of them is going to have an interesting planet. Let's go there. And so his idea is to send these nanosats. They're like, each one is like less than 1 gram. They're tiny little things. But on that 1 little gram of nanomaterial, you've got cameras, you've got propulsion, you've got power, you've got everything on this tiny little chip. And then it's powered by a light sail that's accelerated by lasers. I mean, it all sounds like science fiction, right? It sounds like, whoa, that's crazy. But it's actually something that the engineers are building. So this is feasible. He thinks that he can do this within like the next 10 or 20 years.
Your world is changing.
Yeah.
All right, let's head up here.
If we have an idea of what the Goldilocks zone is, and we have an idea of what we know some characteristics of life is, how do like algorithms or technical processes allow for seeing signs of life that don't fall within our expectations?
That's such a great question. We are very myopic in a way because we only have this one example of life, which is life here on Earth. I mean, life on Earth is very varied, but it all probably has a common origin, right? So we have this one example, and we go searching for what we know. But in that process, we're going to sample the atmospheres of planets, or we're going to characterize the atmospheres of all these planets, and we're going to really start to build up a statistical census, right? And what you might look for are atmospheres that are not in chemical equilibrium. There's like stuff going on constantly, it's changing, which would be an indication of a non-geological process on the surface, because geology takes a long time to happen, right? Life is quick, it evolves quickly, there's lots going on. So I kind of suspect that we'll start to classify planets, I mean, if you look at the atmospheres of planets in our solar system, somebody said you've got like Venus that has carbon dioxide, Mars is kind of like that too, and then Earth kind of sticks out like a sore thumb. It's very different. Its atmosphere is very different. But these are just a small number of examples. Now we go out and we characterize the atmospheres of lots of planets, and we start to put them in these categories, and I think we're going to find interesting things. Then you'll be able to have something to go on, right? Okay, here's an atmosphere, it's not in equilibrium, it's got these constituents, what could be causing it, right? And then you can start to think about other weird biologies. But until then, we just have nothing to go on. That doesn't stop people from working on the subject. There are people who imagine like sand people, weird kinds of biologies that might exist out there, and what kinds of liquids might facilitate their metabolisms and all that kind of stuff. People study that.
You said sand people?
Yeah, like
Cool.
because
Going back to
yeah,
Star Wars.
That sounded so racist.
You mean like native?
Goddamn sand people!
You mean native Tatooiners?
Take over our planet. That's why I vote Trump, man.
Do you mean like animals that live off of sand, like
or,
the way that
or
we
are
do
made
water?
of silicon.
Oh.
Silicon is a really, really common element in rocks.
And in Kardashians.
Ooh. If only they could hear that right now. You burned them.
Kim's watching.
Keep up with that.
All right.
All right. Hey, people still want to talk.
I'm glad you guys got revived there with the sand people. That's good.
We've been in it the whole time, man.
Yeah, we're hanging out.
The questions got it down a little.
question about, so if there are potentially other biological ways for life to upspring, what about in the cases of the methane ecosystems on Titan?
Titan. Yeah, Titan is another example. So hydrocarbons exist in liquid state at very cold temperatures. So there are probably hydrocarbon lakes on Titan, which is one of these moons in the outer solar system. It's very cold there. But it does exist in liquid state, and maybe that's a solvent that could facilitate life. And so people think about that whole chain of possible biology there. The issue, of course, is that the temperatures are really cold. So what is the energy source? You need energy in order to do stuff, to make stuff happen, and create complexity. And it's very cold, so it's going to be harder. I think he wants to say something.
Yeah. You got a new friend. That's an exoplanet.
This is the man that's going to be making, along with Steve, the conference for the next 2 days, as well as this show happen. So let's just give a big round of applause to not only the audience, but also to Dent and.
Hey. Nice. Thank you. Was he just feeling lonely, or?
I just want a little love.
Yeah. Okay, that's fair.
He's telling Alan, stop talking about your story that you're writing.
Hey, I have a cool fact to tell you guys.
This is my
There's
ghostwriter.
a cool fact. Olympus Mons is a volcano on Mars. It's 16 miles high. I mean, that's an actual thing that exists there.
It's bigger than Texas.
It's bigger than Texas. It's almost as big as France. It's huge. And then there's also a crater, 2 craters that are 1,400 miles in. It's the largest impact crater that we've discovered on Mars. And anyway, all these cool things, like the southern part of Mars gets bombarded by asteroids.
Are you a tour guide now? What's going on here?
Are you just saying facts?
You don't know he does Segway tours?
Yeah, I was about to say. I think.
I'm telling you, there's a lot to learn about
That's
what
great.
exists in the world. She knows.
Wikipedia is amazing.
So
Well, you too can check it out.
So thank you to all the viewers at home for watching our live stream. Thank you to the audience for making the show. Thank you to Natalie. Thank you to our comedians.
Thank you.
Yeah. Comedians.
Thank you, guys.
Yeah. Thank you so much.
This place right now almost feels like a hot gaseous planet. I think with the sun, I think we're going to escape to somewhere colder, I think.
And we would like to mention an upcoming show that we have. We will be sitting on a Fears of Biotech panel on October 3rd at 7 p.m. at Many Labs. We will also be on October 4th, the following day. We will be hosting Dr. Lauren Benedict, who is a nuclear physicist at Lawrence Livermore Labs.
Do they call him Dr. Pound?
Dr. Pound?
Yeah, because he says a doctor and his initials are LB.
Oh, good one. Good one.
Non-stop punnage.
All right. NatashaMuse.com.
You've got tons of them.
Yeah.
Also, huge thank you to Piano Fight. Thank you to the crew. Thanks to the venue. Please go drink, go eat, tip your servers, bartenders.
All right. I know.
Technicians. And thank you to Kickstarter for the sponsorship. Have an awesome Dent Space Conference the next 2 days. Yeah.